Section 16 is going to introduce a new type of function called the rational function. Now, the nice thing about the rational function is that it can be created by using two polynomials, much like we can create a rational number using two integers. So what I've given us here in example 16.1 is an example from section 5. So you can refer back to example 5.2. And here I have two functions defined for us. We have function f, whose equation is f of x equals 2x squared minus x minus 3. And then we have g, which is given by the equation g of x equals x plus 1. Back when we discussed functions in section 5, we talked about how to combine two functions together using the elementary operations. We also talked about doing so with a composition. So on this particular example, I want you to define g minus f, f times g, and then g divided by f. Since we've already done this example back in section 5, I want us to use this as a means to get us into the definition for the rational function. So I'm going to give you these results. G minus f. The definition for g minus f will be that the domain is all real numbers, which will map to other real numbers, given by g minus f of x is equal to negative 2x squared plus 2x plus 4. So we're just subtracting the two equations for f and g. The next combination is f times g. We'll call the name of this function fg. It will also have a domain of all real numbers, and its equation is given by fg of x is equal to 2x cubed plus x squared minus 4x minus 3. And the final combination was one of the combinations that was the most challenging, and that was the division g divided by f in this case. And with g divided by f, you'll end up saying that the domain cannot be all real numbers. And what we end up getting is a domain that has two restrictions. It has a restriction of -1, and it also has a restriction of 3/2. And that results in three intervals unioned together to represent our domain. And the domain, by definition, always has to map to real numbers, given by the equation g divided by f of x is equal to 1 over 2x minus 3. So I want to take a moment to reflect on what just took place. The original functions we started with, f and g. F is a quadratic equation. G of x represents a linear equation. Now, both quadratic and linear come from the same family. These are polynomials. So I am asking you to combine two polynomials together. Now, when you subtract these two polynomials with g minus f, the result is another polynomial. And it happens to be another degree 2 polynomial, or quadratic. For multiplication, f times g, your result is also a polynomial. It's a degree 3 polynomial now, but it is still a polynomial. But with division, you are going to create something that does not look like a polynomial anymore. This looks like a ratio. Hence, we're talking about rational functions. Polynomial functions are the building block for a rational function. Q definition 16.1. It says, a rational function is a mapping and function with equation of the following form. R of x equals P of x divided by Q of x, where P and Q are polynomial functions. This is telling us that we have to have two polynomial functions. One will represent the numerator, the other will represent the denominator, and this is what we call a rational function. And because we're creating a ratio, we have to be worrisome about the denominator. And there's that restriction here that says Q of x is not allowed to be equal to 0. This is going to help us define our domain restrictions, and essentially we're going to be looking for just division by 0 type restrictions.